Okay. All right, we're going to look at example 7, the rotating camera problem. The camera is mounted 3,000 feet from the Space Shuttle launching pad. So the first thing we're going to do is draw a picture of this. All right, so you got the ground here. You've got your Space Shuttle. He's running up there. And then you've got the distance there. Okay, so here's our camera. Here's the launching pad. And the Space Shuttle is right up there. Okay, the camera needs to pivot as the shuttle is launched and needs to keep the shuttle in focus. If the shuttle is rising vertically at 800 feet per second, okay, we need some variables. We're going to call this X, Y, and Z. 800, it's rising vertically at 800 feet per second, so that tells us that dy dt is 800. When it is 4,000 feet high, how fast is the camera to shuttle distance changing? How fast, that's asking for a rate, for the camera to shuttle distance. Well, that's z, okay? So we're wanting to find dz dt. Okay, so we're looking for dz dt, that's the camera to shuttle distance, and we want to find the rate at which it's changing. Okay. We also it says when, it's the most important word, when it, that is the space shuttle, is 4,000 feet high. Well, the y represents the distance that the space shuttle has traveled. So when y equals 4,000. Okay. So when y equals 4,000. All right, we are also given that the camera is mounted 3,000 feet from the space shuttle launching pad. That's x. So x is 3,000. And notice that that 3,000, that distance is constant. We're not moving the camera. It's staying put. Y is changing, Z is changing, so these quantities, always ask yourself what's changing and what's constant. Okay, now we need a formula that relates these variables in this right triangle. And that'll be the Pythagorean theorem. So x squared plus y squared equals c squared. And since x is constant here, we want to go ahead and plug our constant values in before we differentiate. Always before differentiation. Sometimes you have constants, sometimes you don't. All right, and then we're going to take the derivative with respect to time of this whole equation. So the derivative of 3,000 squared, we don't care what that is, but its derivative is 0 because it's a constant, plus 2y dy dt equals 2z dz dt. Okay, and the 2's are gone. You can keep them if you want to, but I'll get rid of them. Less work. All right, what is y? Well, y is 4,000. So we're going to plug in 4,000. dy dt is given to us as 800. Sorry about that. 800. Z. Now, what is z? Okay, come back to your triangle. When x is 3,000 and y is 4,000, this is a 3, 4, 5 in disguise, so z must be 5,000 at that instant. Okay, so 5,000 dz dt, we don't know that. That's what we're looking for. And so we just do the math now. We're going to divide both sides by 5,000 and multiply that out and divide it, and we end up with dz dt is 640, what is this, feet per second.